Hello, Algebra 2 people. So that last session we talked about factoring and you got a slew of different factoring techniques. So as you can tell, things are getting a little bit harder as we progress. So it's really important that you guys are practicing these strategies so that you get comfortable with them. Today's also going to be a bit of a challenge because what we're going to do is take all those factoring strategies and apply them in solving polynomials. All right, so we're going to start off with a simple concept that is, how many solutions should you expect when you are solving a polynomial? So that is sort of highlighted right here, that a function will have as many zeros as its highest degree. So for instance, if I have a fifth degree function, then I would have 5 zeros. And remember, zeros has several names. You can call them their x-intercepts, where your graph crosses the x-axis. We call them the roots of the function. We call them the solutions, and we call them the zeros. And a lot of times we will represent a zero or a root. So if x equals r1 is our solution, that means in factored form it would be x minus r to the 1. Okay, so in these first two examples, we see here x cubed plus x squared minus 4x minus 4. So it's in standard form. The highest degree here is 3. That means we would expect to have 3 zeros. Sometimes those zeros will be the same number, repeat zeros, but there'll still be 3 of them. In this next example, you want to read all the way through to make sure it's in standard form. 2x to the 4th minus 3x squared plus 9. Highest power is 4. That means we expect to have 4 zeros. All right? Okay. Hopefully that's a friendly start to this. So now let's try and apply it. So first we see this cubic polynomial. So the highest degree is 3, so we expect to find 3 zeros. Now we're going to actually go ahead and do it. So remember, the first thing you always want to look for is the GCF, which in this case is 2x. So I factor that out. That leaves me with x squared minus 6x plus 9. All of that equals 0. And it turns out that we can still factor what is inside that parenthesis. So here's a 9, a negative 6. So a negative 3 and a negative 3 would multiply to 9, add to negative 6. So the complete factorization here would be x minus 3. Normally I would write it as x minus 3 squared, but I just want to emphasize that you have two factors that are identical. Sorry. So we set each factor equal to 0. So we have 2x equals 0 only if x is 0. And here we would have x equals 3, and you would have a repeat. You do not have to write the 3 twice, but it's not wrong if you do. Now, how does that look? One of my students was really astute and noticed, well, what does that mean on a graph? How do you cross x equals 3 twice? So we want to talk about, because this is one of the next things we go on to after you're solving, is how do you then use those zeros to graph? So we know that if a 0 is at, so we have a 0 at 0, and we have a 0 at 3. So that's where I'm going to cross my x-axis. Those are the x-intercepts. Well, we know it's a cubic function, so remember what you know about cubic functions. That means it's odd, so the end behavior is going in opposite directions. We also know that our lead coefficient is positive, so that tells me my graph will be going up at the very end and start from down here, because it's going to be going in opposite directions as an odd function. So whenever you have a double 0 at a particular point, what happens is your graph is going to come up, and I don't know exactly how far, we don't really care, should go through 0, sorry, almost missed it there, comes down and it actually bounces. So you have a turnaround there. So we have the 2 turnarounds, which also helps us know it was cubic, but you bounce whenever you have a double 0 at that point. And so that's how that would look. Okay, so my zeros, if I just had to list them, I would only list x equals 0 and 3. knowing that 3 has what we call multiplicity 2. Okay? All right, so that was a nice simple solving. That wasn't so bad. What happens if you get something that's a little more complicated and you don't know how to start? You can't just pull out a GCF and then do your quadratic factoring. Well, we have strategies for that. So if you have a really long polynomial, like we do here in generic form, there's going to be a lead coefficient and there's going to be a constant at the very end. And it turns out that a combination of the factors of those first coefficient and the last term will tell us what a potential zero might be. So the way this works is you take all the factors of the first lead coefficient, we call that Q, and we make a list of those. And that goes in the denominator. Then you make a list of all the factors of the constant, we call that list P, and we list those in the numerator, and we know that the potential zero is going to come from that list. All right, so let me show you how this works. Down below here, we have f of x equals 3x to the fourth plus 2x cubed minus 3x squared minus 8x minus 4. So my lead coefficient is 3, and my final constant is -4. So I make this ratio, P over Q. So Q goes with the first term, P goes with the last one. So what are the factors of 3? There are not a lot of them. You're going to have a plus or minus 1, and you'll have a plus or minus 3. How about 4? Well, 4 has the, let me see, everyone has plus or minus 1 because 1 goes into everything. 4 also has plus or minus 2, and it has plus or minus itself, 4. So those are all the factors of the last term and the first term. So if I have to make a list of all the potential, and again, these are the possible, these are not the actual zeros, and we'll talk about how you distinguish in a second. But if I had to make a list of all of these, I start by matching up each one. Oh, sorry, that was not what I wanted to do. I start by matching up my terms in my numerator with the ones in my denominator. So I'm going to first take the plus or minus 1 in the denominator. So on top, I've got plus or minus 1. Then I'm going to have plus or minus 2. And then I'm going to have plus or minus 4, because those are all over 1. And then we continue the list, but now we're going to use the plus or minus 3. So it becomes plus or minus 1/3, and then I have plus or minus 2/3, and lastly I would have plus or minus 4/3. Now, for practical purposes in our course, if I ask you to list all the possible rational zeros, this is going to be like a multiple choice question. So it's basically just figuring out what are the factors of the first and the last term, where the last one goes on top and the first one goes on bottom. And then you're just making a list. Now, what does this mean, though? Remember, what does it mean to be a zero? It means that if I take one of these numbers, let's say the +1, and I plug it in, and I evaluate that function for that particular number, if I get back 0, then that tells me that x minus 1 is a factor of that polynomial, and I can synthetically divide and get my depressed polynomial and then move on to another strategy. If 1 didn't work, then I'd go on to the next term. And I can promise you that for any of this, because we don't want to waste your time, because there are better ways of finding your zeros than this, given modern technology. But to utilize this skill, it's kind of nice if you don't have the technology there. You can kind of just look at the last term in combination with the first lead coefficient and find some possibilities. So let's try it. Here we have, you are going to be so proud of yourself when you are done with this, promise me, because this is going to be a big problem. It's a quartic. You have not factored a quartic, and you are about to. But we look at that and it's like, okay, there's more than 4 terms, I can't do factor by grouping, I don't see a GCF, I have no idea. but I do know that my last term is minus 4. So whatever, and my first term was 1. So whatever is a potential 0 will have to be a factor of 4. So we're going to start at the very beginning, and we plug in 1. And if I plug in 1, I get 1 plus 2 minus 3 minus 8. This is a good exercise just to do with your calculator, and I'm just trying to show the work that you would do. So 3 minus 3, negative 8 minus 4. If you add all that together, you get negative 12. That tells me that x minus 1 is not a factor because I did not get 0 as my remainder. So we go on to the next potential 0, which would be negative 1. So that's going to be 1. This will turn into a minus 2 because x cubed will be negative. Then minus 3. And then minus 8 times a negative 1 is a positive 8 minus 4. So negative 1 minus 3 is negative 4 plus 8 is 4 minus 4. Voila! We hit exactly what we want. And again, I promise you it will come very soon. So this tells me that x minus a negative 1 is a factor of that polynomial. So yay, what do we do with that? So we do our synthetic division now. I take this negative 1, goes in the box. I take the coefficients of my polynomial, making sure I have a placeholder for all the powers of x. So 1, 2, negative 3, negative 8, negative 4, and we draw the line. Remember, you drop that first coefficient, and then we multiply and add. So negative 1 goes here. We add. That'll be a negative 1, and we add. That's going to give me a positive 4, and we add. That gives me a positive 4 again, and we expect to have a 0 there because remember the remainders are the same whether you just plug in the number or do your synthetic division. Now here's where I know some people are struggling is how do you write that final answer as a polynomial? So remember you just divided x to the 4th by x, and so that means the first term here is going to be the coefficient on x cubed, 1 degree less. Then the next term we just kind of go down in descending order. So 1x squared, then we have minus 4 goes with just x, and the last is just our constant because we have no remainder. So let's bring this up here because I'm running out of room. X cubed plus x squared minus 4x minus 4. All right, so we have one of our zeros and one of our factors. We want to find the other 3 because I know it's a quartic. I'm expecting to have a total of 4 zeros when I'm done. So here I have a polynomial that is now cubic. I have 4 terms. Think about what strategies you would use when you have 4 terms. My go-to strategy doesn't always work, but it's the one I try first, is factor by grouping. So I can pull out an x squared. That leaves me with x plus 1 in those first 2 terms. Then I pull out a negative 4. That also leaves me with x plus 1, because again, negative 4 times x, negative 4 times 1. Notice we have the same factor here, so I factor that out. And what remains goes in the other parenthesis. Now, hopefully you notice something. Hopefully you notice x squared minus 4 can still be factored. That is a difference of squares. So that will factor into the square root of the first term, square root of the last term. Square root of the first term, square root of the last term with a plus or minus. That's why we have no middle term. It got added and subtracted away. So we're setting this all equal to 0. So this one gives me x equals negative 1, x equals negative 2, and x equals 2. And when you combine that with our original, x equals negative 1, there are your 4 solutions. And that's pretty cool. You guys just factored and solved a quartic function. All right? So again, what did we do? We looked at the factors starting with 1 and -1 of the last term. You plug it in and you keep working through those factors till you get a 0. Then you do your synthetic division, which gives you a depressed polynomial that you can then use other strategies on. Okay? Now this next part, it actually, believe it or not, you've already done this, you just don't realize it. When you do the quadratic formula, you know how we have opposite of b plus or minus radical? Anytime you have a positive number under that square root, or even the complex numbers, there's always 2 of them. You always have 2 complex or 2 real roots. And so what this is saying is, this is just actually putting that specifically into words. So when you are finding the zeros of a polynomial, and the zeros happen to involve a square root, and later we'll see that it also, if it involves an imaginary, they come in conjugate pairs. So in other words, you're used to seeing this as a plus or minus the square root of b. They always come in pairs. And a can be 0. So I could have just, like when you do the square root method, sometimes you just get plus or minus the square root of b. That is still a conjugate, the plus square root of b and the minus square root of b. The other thing that's helpful to remember is when we factor, we tend to factor it into x minus root 1, x minus root 2, x minus root 3, etc., depending on the degree of our polynomial. So we're going to use this fact and the fact that they're going to give us some zeros to find the original polynomial. However, this can be very time consuming, so I'm actually going to do 2 examples, because the first example here, I just expect you to be able to simplify. The second example that I'm going to write down, and this should be a 6, I will expect you guys to be able to boil that out into a polynomial. So let's see how this works. So notice they gave us the zeros of 3 and the 0 of 2 plus rad 5, and they want us to write a polynomial of least degree that has rational coefficients, that means no square roots, with a leading coefficient of 1. Well, we're just going to leave it in factored form, so we're not going to do the whole polynomial. The first thing to realize, though, is there's a third root that has not been written. It'll never be given to you. You have to know that it exists, and that is going to be the conjugate of 2 plus rad 5, which is 2 minus rad 5. So there are my 3 roots. I am going to use this format to write my polynomial. So I start off with x minus 3, then x minus, in parentheses, 2 minus, or I guess I'll do 2 plus rad 5 first. Then we have x minus, in parentheses, 2 minus rad 5. And that looks like a big, lovely mess, right? So all you have to do, so I expect you to understand that there's going to be the 2 conjugates, and to simplify this so that we don't have parentheses inside of parentheses. So the first term is just x minus 3. That one's simple. The second one, I'm going to distribute the negative. So x minus 2 minus rad 5. This last one is going to be x minus 2 plus rad 5. To FOIL that out and distribute it, there are tricks and small shortcuts, but it's not really something that we're going to be doing a lot of, so I don't really see the point of pursuing it right now. However, let me give you an easier example that I would expect you to be able to do. Okay, so notice what we did. We did have to find that conjugate root. We put it into our, what you'd call our intercept form, and just simplify it enough so you don't have parentheses inside parentheses. This second example, let's say I gave you the zeros of, let's say it was a -2 and a square root of 3. Okay, well, first step is I expect you to realize there will be a third root, which is the conjugate of rad 3, which is negative rad 3. They always come in conjugate pairs. So now we write x minus a -2, x minus rad 3, and x minus a negative rad 3. So to come up with a polynomial for this is actually not that hard, because notice x minus root 3, x plus rad 3. Well, if you remember, when you do the difference of squares, the difference of squares factors into a plus b, a minus b, which is really our conjugate form. So I have here a minus b, and a plus b. So I can FOIL these together. I mean, you can do the first, outer, inner, last, that's fine, but there is a shortcut here. This simplifies to x squared, the first term squared, minus the last term squared. So rad 3 times rad 3 is 3. And then we're going to FOIL that against x plus 2. So we do our first terms, which is x cubed. We do our outer term, minus 3x, inner term, plus 2x squared, last term, minus 6. That is not in standard form because we need to switch these two terms. So the final answer would be x cubed plus 2x squared minus 3x minus 6. Now notice, I could actually do factor by grouping, which would be just going in a big circle, and I would get back to my zeros, which are right here. Okay, so the main thing here is realize conjugates always come in pairs. Always, always, always. So if you've got one radical, you're going to have the other. Okay. This last example, I used to do this a much different way, and it emphasized, it solidified your understanding of synthetic division. And then a student came up and showed me an easier way, and so now this is almost kind of a silly example, but I'm going to do it anyway. So we have this polynomial here, and it's set equal to 0, and notice that there's an unknown coefficient in here. So it's like, oh, okay, so what is that k to make this equal 0? So we want to find that k, but we want to find the k given that we know x equals 3. So what am I going to do? I'm going to plug 3 in for x. So 3 cubed plus 3 times 3 squared plus k times 3, so that's 3k, minus 24 equals 0. So we have 27 plus 3 times 9, which is 27, plus 3k minus 24 equals 0. So this is 54 minus 24, and we end up, that is going to give me 30. So we have that 3k is going to equal a negative 30, which means that k will equal a negative 10 if we divide both sides. So turns out, I mean, that's not very interesting to me. It was better as a synthetic division because it showed, I don't know, the process and understanding the process. But if all you're after is solving for k, that is probably the easiest way to do that. All right. So good luck with the classwork. It is going to be challenging. Keep your notes handy because you're going to want to be able to refer to them.